This video is going to be a short review of going from compound name to the compound formula. The first step in order to successfully do this is to determine if the compound is going to be ionic or covalent. And to refresh your memory, an ionic compound is one that contains a metal and a nonmetal, while covalent compounds contain nonmetals only. If you look at the periodic table, the greenish ones, these are all the metals found on the periodic table. The yellowish ones are all the nonmetals found on the periodic table. These blue ones that separate them, these are called metalloids. They have properties of both metals and nonmetals. For the most part, they covalently bond, but we won't focus on them too much. So for our first example, we'll work with lithium chloride. Now looking at the name, we have lithium and chloride is chlorine. So looking back at the periodic table, I know the names aren't on here, but lithium is Li, which means it's a metal. Chlorine is Cl, which means it's a nonmetal. Therefore, lithium chloride is an ionic compound. Just to go back even further, lithium is in group 1A, therefore it has one valence electron. Chlorine is in group 7A, therefore it has 7 valence electrons. And one of the differences between ionic compounds and covalent compounds is that ionic compounds, the electrons actually transfer. Which means the electrons are actually moving from one atom to another. So lithium has one valence electron. It's much easier for lithium to lose that one electron to be stable. Chlorine has 7, you need 8 to be stable, so chlorine only needs to gain one more. Therefore, lithium actually gives its electron to chlorine. When this happens, lithium becomes stable. And it gets that's a positive sign. It gets a positive 1 charge because it lost one negative electron. Chlorine gained 1 electron to become stable, so it has a negative 1 charge. Because it only took 1 lithium and 1 chlorine, the formula for this compound is LiCl. And that's it. It only took 1 lithium, 1 chlorine. And if you remember, there was a shortcut that we called the crisscross rule. Crisscross rule. And the crisscross rule states that you take the charges and you cross them down. Take the charge and cross it down. At this point, the positives and the negatives don't matter. It's just a matter of how many they're going to be. Since it's 1 and 1, we don't have to write those down, so we just get LiCl. For our next example, we're going to use lithium oxide. Since we're using lithium again, it is a metal. Oxide is oxygen, is a nonmetal. Therefore, lithium oxide is also an ionic compound. Lithium still only has 1 valence electron. Oxygen has 6. 2, 3, 4, 5, 6. Lithium will still lose its electron, give it to oxygen. Lithium is stable. However, when oxygen gains this 1 electron, it only has 7 valence electrons, so it is not stable yet. So what happens is we actually have another lithium that comes and gives its electron to oxygen as well. Now oxygen is stable and both lithiums are stable. For this formula, it took 2 lithiums. So we show that by saying Li2, 2 lithiums. There's only 1 oxygen, so we just put the O. For the crisscross rule, for the shortcut, lithium, being in group 1, will lose its 1 valence electron and have a positive 1 charge. Oxygen is in group 6. It needs to gain 2 electrons to become stable, so it will have a negative 2 charge. Take the number, bring it down. Take the number, bring it down. Li2O. Same thing. The cation, the metal, will always go first. The one that's positive, the one that's losing its electrons will always go first. Okay. Magnesium oxide, if I look back at the periodic table, magnesium is Mg. Oxide, of course, is oxygen, so this one is also an ionic compound. So I'll start off with magnesium. This time magnesium is in group 2, so it has 2 valence electrons. Oxygen in group 6 still has 6 valence electrons. 6. Magnesium will lose both of its electrons to oxygen, since oxygen needs to gain 2 electrons. Magnesium stable, oxygen stable, the formula MgO. 1 magnesium, 1 oxygen. If we do the shortcut rule, magnesium has 2 valence electrons, will be a positive 2 charge. Oxygen has 6, will be a negative 2 charge. If we were to crisscross, we get Mg2O2. However, the 2's simplify, cancel out, I don't care what wording you use, but they're not going to be there. They're going to be 1 and 1. Just remember, if there's a polyatomic ion involved, that means from that chart where there's more than 2 elements and it is ionic, that the polyatomic ion has to stay together. Okay, last example, carbon tetrahydride. Carbon is a nonmetal. Hydride would be hydrogen, also a nonmetal, which makes this a covalent compound. For covalent compounds, it's much easier to determine the formula because covalent compounds use prefixes in the names of the compounds. Carbon, there is no prefix there, so it's just 1 C. Hydride, we said was hydrogen, but then we have tetra here. Tetra lets us know that there are 4 hydrogens. And that's it. Carbon tetrahydride is CH4. Here's a list of the common prefixes that we use. We only use mono on the second part of the word, of the name. We never use mono in the first part. Notice that it's not monocarbon, it's just carbon. Okay? If we have carbon monoxide, that would be CO.